Today we've been asked to find the domain of the following functions. Function number 1, y equals 5x to the 5th minus 3x to the 3rd plus 2x minus 7. There are only two restrictions that will make the domain anything but all real numbers, and they are a variable in the denominator or an even radical. And when I look at this question, I see no fractions, no variables in the denominator, and I see no even radicals. And so the domain of this function is very simply all real numbers. And remember, the domain of this function is what numbers are you allowed to plug in for your x values. Okay? And there's nothing that says you can't plug in anything you want to for these x values. Now with the next two examples, let me demonstrate some actual domain restrictions. So we have y equals 4 times 3x minus 2. Now here's the trick, folks. This is an even radical. Even radicals cannot be negative or you'll get an imaginary answer. And so given that, what do I know? I know that what's inside of this square root cannot be negative. So I say to myself, okay, 3x minus 2 equals 0. Whatever makes this 0 is fine. Whatever makes this positive is fine. Whatever makes this quantity here negative cannot be inputted into this equation. Cannot be input into this equation. So 3x minus 2 equals 0. We get 3x equals 2. X equals 2/3. Okay? Now what that means is if x equals 2/3, 3 times 2/3 is 2. 2 minus 2 is 0. Anything less than this number will cause this radical to be negative. And you can't take the square root of a negative number. So that means the domain of this function will be 2/3 to infinity. It can be 2/3 or it can be higher. And I'm actually going to use a bracket here. 2/3 to infinity. Why do we use the bracket? Well, because if x is 2/3, this radical is exactly 0. And the square root of 0 is 0. And 4 times 0 is 0. And that's allowable. So it can equal 2/3. That's what the bracket means. Or it can be larger than 2/3. Go all the way to infinity. It cannot be less than 2/3. In the example I use, a number less than 2/3 would be 0. So 3 times 0 is 0. 0 minus 2 is -2. What's the square root of -2? You can't take the square root of -2. Therefore, that can't be part of the domain. And any number smaller than that will also give you a negative number. Okay? Here we have a 17 over 2x minus 10. Again, the only two domain restrictions you ever have are going to be square root or an even root, second root, fourth root, sixth root, or a variable in the denominator. Here I have a variable in the denominator. Because one of those math rules that you should know quite well is you cannot divide by 0. You cannot divide by 0. Is there a number that I can plug in right here that will make this 2x minus 10 equal to 0? There is. And so I say, okay, 2x minus 10 equals 0. Solve this, you get 2x equals 10, and you get x equals 5. What does this mean? This means if I plug in 5, 2 times 5 is 10, 10 minus 10 is 0. If I plug in x equals 5, I get 17 divided by 0. This cannot be. What about a number less than 5? That will work. What about a number greater than 5? That will work. Only 5 won't work. So the denominator here would be all real numbers except 5. And to write that in interval notation, we always start at -infinity or the lowest number in the domain. And we will go all the way to 5. And we put a round bracket because we don't equal 5. And then we're going to put a union and 5 to infinity. What this means is we go up almost to 5, skip it, and start just to the right of 5 and keep going. That's what this means. And that would be our domain for this particular problem. Okay? The last problem we have, y equals 3x squared plus 2x minus 3 over the square root of 2x plus 4. Now we have two domain restrictions. This can't be 0 because it's in the denominator. And that would be dividing by 0. And it can't be negative because it's under a radical. So now we have two restrictions in one problem. Well, real easy to find. 2x minus 4, take what's under your radical, set it equal to 0. Okay? So you get 2x equals 4, x equals 2. Now what this means is, if x equals 2, this radical will equal 0. That takes care of this. In other words, x can't be 0. This radical can't be 0, so x can't be 2. This radical can't be negative, so x can't be anything less than 2. So what is your domain? Negative infinity. Well, we can't start at negative infinity, can we? Can't start at negative infinity because anything less than 2 would be off the table. So your domain is going to be from 2 to infinity. Now, big question here, square bracket or round bracket? Well, if x is equal to 2, this will be 0. That's division by 0. So it has to be a round bracket. What does this mean? This means it can be anything above 2 all the way to infinity, but it cannot equal 2 because we would have a square bracket if it equals 2. So that is the domain for this problem. If you have any questions, please come see me.